Well, hey there, kiddos. I'm sorry I'm not there with you today. I've been pulled out for a meeting this morning, but I will be back this afternoon if you need to come ask some questions. So we're going to finish what we started yesterday. You should now have notes, though, with the problems on them so you don't have to do so much writing. You're also going to need your homework packet out, so at the end of this video, when I tell you what homework problems to do, you can circle them. And you also need a calculator if you have one. If you don't, share with a buddy so you can see what's going on, because we are going to be using calculator quite a bit. So back to what we talked about yesterday with the vertical motion problems, the physics stuff. We have a question about a cannonball being fired from the ground with an initial upward velocity of 300 feet per second. It's being launched. So that means we have to go to that equation. We wrote those down yesterday. You put them in your notebook. The equation for launching something, and this is in feet, so we need the feet per second one. So to write an equation to find the height of the cannonball, it's going to be h of t, and it's the negative 16t squared one because we know it's in feet per second. Upward velocity means it's going up, so it's going to be positive, and that means the initial velocity was 300t, and it's being fired from the ground, so the initial height is 0, so I don't need to add the plus 0. So there is my equation. Now part B here says to determine an appropriate viewing window. That means that they want you to look at your calculator and figure out, if I were going to graph this equation or this function, what would my window need to be so I could see the whole thing. First of all, here's what I do know. I do know that I am talking about something being fired from the ground, and I'm talking about time and distance. We're not going to be dealing with negatives here, so I know that when my minimum values don't have to be very much smaller than 0. I always go a little less than 0 because I only want to see the positives, but if you go right at 0 and you start x min is 0 and your y min is 0, sometimes you can't see some of the things that are happening at the very edge of the graph. So I always like to go a little outside of that. So I'm going to make my x min and my y min both negative 5. Now I'm going to go to my calculator though, and I'm going to plug this equation in to sort of gather what the rest of my viewing window needs to be. So I'm going to grab my calculator, and in y equals, I'm going to put that equation that I just created, the negative 16x squared plus 300x. That was then, I know we wrote t's, but we're going to replace them with x's for the calculator. And I have the 0 here. I'm going to clear it out because I don't need it. Now, the graph is unimportant right now. I need to set a window. So what I need to look at is my table of values so I can sort of see where the maximum height, the maximum y value, and all of that is going to happen, so I can determine where my window should go. So if I go to second and graph, it will bring up the table. And I can sort of see my values. I've got negatives here, so I know I don't need those. I can see it starts at 0, 0. I've taken care of that minimum value with my negative 5. So I'm going to arrow down so I can see what happens. And if you look at your y values as you go, they get bigger and bigger and bigger. And so we're going to keep arrowing until we see where it turns around and it starts getting smaller again, because that lets me know that that's where it changed direction, so that's where I hit the vertex. And it looks like that happens right in here somewhere, because they're getting larger, the numbers are getting bigger and bigger and bigger, and then they start to get smaller. So here is my maximum y value. It needs to be somewhere around 1404. So when I write my window for my maximum y value, it needs to be more than 1404. So let's set it at 1420. Now, since I'm going that big, I do not want my scale to be ones. I don't want my graph to count 1, 2, 3, 4. That's a lot of tick marks on a graph, and it's going to make it look very squished up. So I'm going to make my scale go by 100s because I'm counting so far up. I'm going all the way up to 1400. So I'm going to have my scale go by 100s when I get there so I can look at it. Now let's go back to our calculator and look, because I want to see when this gets back down close to 0 or exactly 0, because that's how far I need to take my x values out. And so it's going to keep decreasing until somewhere between 18 and 19 it switches from positive to negative. So somewhere in here it had to cross the x-axis. So I know that I need to take it out to at least 19 in order to see where it's going to cross the x-axis over here, and that's going to be important. So if I go back to here, I need it to be at least 19, so let's call it 20, just so I can make sure I get the 19 on there. And if I'm going from negative 5 to 20, that's not too bad. My scale can be 1. So what I'm going to do is I'm going to put these values in my calculator under Windows so that when I graph my parabola and I graph this function, you'll be able to see the whole thing because we need to see the whole thing. So in your calculator, press the button that says Window. It's right next to y equals. And we're just going to type in our values. Our x-min was -5. Our x-max was 20. Our scale is going to stay at 1 for the x's. Our y-min was -5. And our y-max was the big number. It was 1420. And so we made our scale 100. Now these other numbers, we're not going to worry about them right now. We're going to leave them alone because we're not going to do anything with them. Later in the year we might, but for today I've set my window. If I graph this now, you should be able to see the entire parabola. We would not have been able to see the whole thing before, which is why we had to go set the window. So now you can see the whole parabola. You can see it goes up and it comes back down. So part C asks us to calculate the altitude after 3 seconds. So they want the height after 3 seconds. We did this yesterday. You just need to plug 3 into here so we can find out what it equals. So I have -16 times 3 squared plus 300 times 3. And that's just a simple calculator thing. I'm going to type it in. And this comes out to equal 756. So after 3 seconds, the cannonball is at 756 feet. That's where it is. Now part D says at what times will it land on the ground? When is it on the ground? Well, the ground is at height 0. You have two options here. You can plug 0 into here and find out what it equals, or we can go to our picture. We have a graph, and I can see that here it's on the ground and here it's on the ground. Well, this was when it was launched at time 0. That's when it's on the ground. It didn't hit the ground there though. We launched it from here. It went up, came back down. And this is where it hit the ground, and I want to find that point. So this is where I go back to y equals, and in the second equation I'm going to put my 0 back, because then when I graph it, it will show up on mine, but not on yours because you don't have the color screen. But it will now draw this line, and I can now go ask my calculator to find out where this parabola and this line intersect over here. So I'm going to go to second trace. I want the intersection, so I'm going to hit number 5. And I'm going to hit enter twice. So I'm going to go 1, 2. And then I have to make a guess. So I'm going to make this cursor scoot over here closer to that point on the right. It will take me longer than it will take you to do this. And it doesn't have to be all the way to that point, but it does need to be close to it so that your calculator knows to look at that one and not the one on the left. So that's probably good. So I'm going to hit enter. And it's going to tell me that my intersection is at 18.75 and 0. And you see my cursor's blinking on that spot. And so since x is... that's what I'm looking for, is that time. So it takes 18.75 seconds for that to land on the ground. That's when it will be there. Now the next question is, when does it reach its highest point, and how high is it at its highest? Well, that is the vertex of our parabola, and we have it right here on the graph up here. And I can have my calculator go find that point for me so that I can know what the x and the y value are. Instead of plugging in values and using my formula for the vertex, the calculator will find it. Since this is at the top of the parabola, it's the maximum. So we're going to do second trace again, and this time we're going to find the maximum. So we're going to choose option 4. Now this is going to ask some questions. The first thing it asks is for the left bound. It wants you to take this cursor and move it until it's to the left side of your vertex. It doesn't have to be way far left, but it's got to be to the left. And right now it's not. Right now mine is to the right. So I'm going to have to hit my left arrow until I can get that cursor over there to the left side of my vertex. And it's going to take just a second. Okay, so now my cursor is to the left, and I'm going to hit enter, and you're going to see it drew a line. Yours probably put a little arrow right here. It's the same thing. What it's doing is it's marking this is the left side. Now it says right bound, so it wants you to move your cursor to the right side of the vertex. There's my little arrow right there. I'm going to move my cursor so it's on the right side of the vertex. About right there looks good, and I'm going to hit enter again, and you see it's drawn the line. So now it's marked. It's telling the calculator the maximum is somewhere between this point and this point. Now for the guess, I'm going to move my vertex to the very top where I think it is, and I'm going to hit enter. And it's going to tell me that's where my maximum is. Now our directions yesterday, they're not still on there, but the directions on our notes yesterday said that we needed to round to 3 decimal places. So that's what we're going to do. Here's my x value to 3 decimal places. This becomes 9.375. Well, x is my time. So when does it reach its highest? It reaches its highest point at 9.375 seconds. How high is its highest point? That's this value over here. And if you remember when we looked at our table, it went from 1404 to 1400, so we knew somewhere in there it was going to change direction. Here's where it changes the direction at 1406.25. So its highest point is 1,406.25 feet. And that's how we find that. We just used our calculator, looked at the parabola, and did our math. So let's talk about this next one. We have a squirrel. It's a silly squirrel. This squirrel attempted to jump from a tree to a house, but it didn't quite make it. He fell. So he went to jump and didn't make it. Like I said, not a smart squirrel. We want to know how long it takes for the squirrel to hit the ground if his initial height was 15 meters. Well, if the squirrel is jumping from a tree to a house, the first thing you have to decide is, did he launch himself or did he drop? And I guess there's 2 ways to look at this. There's more than one way to approach this problem. So what this problem tells us is that the squirrel attempted to jump. It doesn't say he actually did. He attempted to jump, but he really didn't jump. He just fell. And so when he left the tree, he just dropped. And so this is not a launching, throwing kind of problem. He doesn't have any initial velocity. He just started and he tried to jump, but he didn't. He fell. I do, however, know what his initial height is, and it's in meters. And so this is a dropping kind of question. So I'm going to use my formula for dropping. So I have h of t equals negative 4.9 t squared. This was his initial height, so plus 15 t. That's going to be, doesn't have the t, I apologize, it's just plus 15. We only have to add the t if we've got velocity. We don't have velocity. So here's your equation, plus 15. We need to graph this in order to figure out how long it took him. I'm trying to find out where he hit the ground. Where was it 0? So I'm going to go back to my calculator and I'm going to go to y equals, and I'm going to type in that equation. So I have negative 4.9 x squared plus 15. That's going to be my equation, and I want to graph that. But I'm going to, if I graph this now, it's going to be in that window I used a minute ago, which is probably okay. Not really. You see, I can only see the very tip of my parabola right here, and it doesn't really help me. So in order to fix this, I'm going to press zoom, and I'm going to choose option 6, which is my standard window. And so that'll take my screen back to the way it always looks. And then it'll graph my parabola, and now I can see. And I don't care about the vertex up here. That's not what I'm looking for. What I'm looking for is down here at 0. Where did he hit the ground? Over here doesn't matter because this is going to be a negative value. This is going to even have occurred before he ever jumped. He left the roof and fell. This is where he hit the ground. So I need this point right here. So this is an intersection. Second trace. I want to do the intersection. So I'm going to hit enter twice. And then I'm going to take my cursor and I'm going to arrow it to this one on the right so that I can say look over here, and I'm going to hit enter, and it tells me that my intersection is at about 1.75. And I know that said to round to 3 decimal places, so I will. It takes him 1.750 seconds to hit the ground. So let's do one more that's like that, and then we're going to switch gears and do something different. So an object is hurled upward from the ground at an initial velocity of 128 feet per second. So somebody threw something up in the air. The height in feet of the object at any given time is given by that equation. H of t equals negative 16t squared plus 128t. They already wrote the equation for you. They just asked some questions like when does it reach this many feet and when does it reach the ground and all of that. So we're going to use our calculator just like we've done with everything else. We're going to go to y equals, and we're going to put in that equation. We're going to put in the negative 16 x squared plus 128x. So I have my function in there, and if we graph it, that's okay. But if I leave it in this standard window, we're not going to be able to see much of anything. I can see one side, there's two sides of the parabola, but it asks for more than just those little pieces. It wants to know about the whole thing. So I'm going to have to go look at my table. So I'm going to go over here to my table, and right now I'm in nothing but negative numbers. So I'm going to have to go up in my table until my y values stop being negative. And you can see what happens here. I clicked too many times, I apologize. This function works out very nicely. You can see right here at 0, 0 it starts, and right here at 8 it's back at 0. So I know that it took 8 seconds for whatever this object was to hit the ground. I can also see my y values go from 0 and they increase at 256, and then all of a sudden they start to repeat. The fact that these numbers are symmetric means that I can tell where my vertex is by looking at this table because they're symmetric. I go from 192 to 240 to 256 back to 240, so the numbers are repeating themselves. So that's a good thing. So I can just use the table to answer my questions. Now, if they skipped around and it started increasing, and then started to decrease without my numbers repeating themselves so symmetrically like this, I'd have to do what I did before and change my window and actually look at it. But I don't have to for this. My table is going to be sufficient. So if I go here, the first question says, when will the object reach a height of 192 feet? Well, it looks like right here it's at 192, and then right here it's at 192. So it takes 2 seconds, and then again 6 seconds. Why does that happen twice? Because it goes up, and then it comes back down. That's why it happens twice. So at 2 seconds, and again at 6 seconds, it's at 192 feet. Now, when does it reach the ground? We looked at that. It took 8 seconds for it to be on the ground. So it reached the ground after 8 seconds. When does it reach its maximum height? Well, where is the maximum height? Increasing, decreasing. Here's the maximum height at 256. It took 4 seconds. And the maximum height was 256 feet. I got that from the table. Now it says to graph it. There is no place for you to sketch this graph, so do this with that little instruction. It does, however, ask for the domain and the range. So we're going to do the domain and the range of the situation of what's happening, or of this graph. We're going to start at the 0 and where it's just the positive values. I'm not real worried about what happens outside the positive because we're going to deal with what the situation would look like. Negatives don't matter for this situation. So my domain would be the x values. And if we look at our table, we're just going to deal with these numbers that are positive. The negatives that are on the other side of my zeros, like I said, don't matter. They don't match the situation. So for my domain, it goes from 0 to 8 because this is where it starts and this is where it hit the ground. So my domain is going to be every value from 0 to 8. My range is the y values, and so that's going to be from 0 because that's where we are going to start at, all the way to the maximum height, which happened to be 256. And so that's my domain and that's my range. I didn't even have to have a picture of it in order to do that. I just knew that it started at 0, it hit the ground after 8 seconds, so there's my range, my domain, and then my range, it started at 0 and topped out up here at 256, so there's my range. So that is vertical motion. You just need to make sure you have your equations from yesterday out in front of you, and you need to read the question and understand, is it a dropped kind of situation, so something just got dropped, or is it something being launched or thrown? And then you have to look at your units. Are they feet or meters? Use the appropriate ones. So now let's talk about a couple of other things. We're going to actually write some quadratics given different things. So what we're going to do now, this is on the back side of your notes, we're going to be given solutions to quadratics, and they're going to ask us to go backwards. They're going to ask us to take those solutions and write what the quadratic was that it came from. So we're working backwards from what we did last week. I'm going to be given the answer, and I have to work back to what the problem was. So this problem right here, they want us to write an equation for this graph. So I have this lovely graph. Here's how I'm going to write the equation. I'm going to find my solutions first. I have a solution here and here. So I know that x equals -5 and x equals -2 because those are my x-intercepts that were across the x-axis. In order to get back to my quadratic, though, I need to make these equal 0 because that's how I wrote the problem. That's how I got the answer. To make this equal 0, I'll have to add 5 to both sides. So this will become x plus 5 equals 0. And I'll have to add 2, so this will become x plus 2 equals 0. So to get to the quadratic, these would have been my factors that I came up with if I had been solving this problem and I had been working from the problem to the solution. Now that I'm working from solution to problem, I have to unfactor, which means I've got to now multiply these things together. So I'm going to take my two factors, I'm going to multiply. Double distributive property. X times x is x squared. X times 2 is 2x. There's a plus sign there. 5 times x is 5x. And 5 times 2 is 10. And then I'm going to combine my two middle terms. So I'm going to have x squared plus 7x plus 10 equals 0. This is the quadratic that when graphed looks like this, and these are the solutions for it. So it's just going backwards from what we did on your test last week and all week last week when we were solving quadratics. So number 2 here says to write a quadratic function in standard form with zeros at -3/4 and 2. Well, what that tells me is that I have x is equal to -3/4 and x is equal to 2. This x equals 2 is easy. I'm going to do like I did over here, and I'm going to make it equal 0. So I'm going to subtract 2 from both sides, and so it become x minus 2 equals 0. This doesn't quite work the same. I can't just add 3/4 to both sides and make it equal 0. I mean, that would work, but that's not where this 3/4 came from. In order to get 3/4, it tells me that I had to have subtracted 3 at some point from both sides, and then I would have had to divide by 4. That's what this means, because I had to solve an equation to get here. So the -3 tells me I subtracted 3. The over 4 means I divided. So to undo that, I will have to multiply by 4, then add 3. So the first thing I'm going to do is multiply both sides by 4 to get rid of the fraction. So that gives me 4x equals -3. And then I'm going to have to add 3 to both sides to get that to equal 0. So these would have been my two factors, 4x minus 3 and x minus 2. And I'm going to run out of room here. But so what I would have to do is I would have to take my two factors. I'm going to erase so that I can make some room. So I hope you were able to get that all copied down. If not, peek at a buddy's notes real quick. My two factors were 4x plus 3 and x minus 2. And to get to my quadratic, I'm going to do what I did with that first one, and I'm going to multiply. So I'm going to do 4x times x is 4x squared. I'm going to do 4x times -2 is -8x. 3 times x is 3x. And 3 times -2 is -6. Combine your like terms, so you get 4x squared minus 5x minus 6 equals 0. And again, if I were to take this and factor it or graph it or whatever, these would be the solutions. This is where this quadratic crosses the x-axis. So I'm going from solutions to problem. Number 3, it tells me my solutions are actually complex numbers. It tells me that I have a quadratic function that has solutions at -2 plus 3i, which means that I had a negative square root at some point. That doesn't really matter for solving because I'm going to treat it like I treated this one. I have two solutions here. I have x is equal to -2 plus 3i, and I have x is equal to -2 minus 3i, because that's what that plus minus means. Now, just like I did with this one and with number 1, I need to make these equal to 0 so that I can multiply the two factors together. Well, to do that, I have to add 2 and I have to subtract 3i. So this becomes x plus 2 because I added this 2, and then minus 3i because I subtracted the 3i, and that equals 0. So I added this 2 to cancel, I subtracted this 3i to cancel, and so I had to do that on the other side. This one, I'm going to have to add 2 and then add 3i. So it's going to be x plus 2 plus 3i is equal to 0. So these would have been what my factors are, and that's not how we typically solve these, but that's how I'm going to get back to the quadratic that it came from. So I'm going to have to multiply these two things together, which is kind of messy. I'm going to do it out here to the side, so I'm going to have x plus 2 minus 3i times x plus 2 plus 3i, and I'm going to multiply those together. So I'm going to distribute, but I'm going to have to do it 3 times. So instead of the double thing here, I'm going to have to do it 3 times. So I'm going to have to do x times x, which makes x squared. Then I'm going to have to do x times 2, which makes 2x. And then I'm going to have to do x times 3i, which makes 3ix. Then I'm going to have to do the 2. And I'm going to change colors here to make this a little easier to see. So now I'm going to do 2 times x, which makes 2x. And then I'm going to do 2 times 2, which is 4. And then I'm going to do 2 times 3i, which is 6i. I'm going to change colors again, and this time I'm going to go on the underneath so that all my stuff doesn't start to mix up. So now I have negative 3i times x. So I have, and I have to write down here because I didn't leave myself enough room. I have negative 3ix. Negative 3i times 2 becomes negative 6i. And then negative 3i times 3i becomes negative 9i squared. So now I can simplify. So I'm going to start simplifying things. I'm going to put like terms together. Well, I have this x squared, and there are no other x squareds to combine. So it's going to start with x squared. Then I have these x's. I've got 2x and 2x. And that's it. So I can combine those. That becomes 2x plus 2x is 4x. Now 3ix and negative 3ix, these cancel each other out because they're opposites. They're going to cancel one another out. Then I have this plus 4. I have nothing to add to it, so I'm going to put plus 4. And then I have 6i and negative 6i. Those will cancel because they're opposites. And then I have negative 9i squared. Well, if you remember, the I squared changes my sign, so this becomes plus 9. So I can combine those. So my quadratic that gave me this complex solution is x squared plus 4x plus 13. And if you were to solve this, you would probably have to use quadratic formula because it gives you a negative square root that you have to deal with. That's where the complex solution came from. But if you were to solve that, that's the complex solution you would get. So number 4 and number 5 are a little easier, which is why I saved them for the end. Number 4 asks you to find the quadratic equation with solutions 3 and 8, and the graph also passes through the point 2, 3. Well, if I have solutions at 3 and at 8, those are x-intercepts. It's where it crosses the x-axis. So that means that my solution is at 3, 0 and 8, 0, and it also passes through this point 2, 3. Well, if I have 3 individual points and I want to know the quadratic this came from, I can use something called quadreg on my calculator to give me the equation. So we're going to go to our calculator. We're going to press this button that says stat. And then we're going to edit. And in list 1, we're going to put our x values. So my x values were 3, 8, and 2. So we're going to put those in. 3, enter 8, and 2. Those are my x values. Then over here, I'm going to put my y values, which happen to be 0, 0, and 3. So I'm going to go put those in. I'm going to do 0, 0, and 3. And so now I have my points in the table. Now I'm going to go back to stat, but this time I want to go over here to calc, and I want to do a quad regression because I'm looking for a quadratic, not a line. So do not choose linreg. That's linear stuff. We're not there. We're going to do the quadreg. So you can choose option 5. And if yours looks like mine, you're going to hit enter until you get down to calculate, and calculates it, that's what should happen. It's going to give you a bunch of numbers. And so I have all these numbers, and I need to put these numbers into this ax squared plus bx plus c. Well, a is 0.5, b is negative 5.5, and c is 12. So my equation becomes 0.5x squared minus 5.5x plus 12. That's the equation. The problem is it says that my equation needs to be in this thing called standard form. And in order for it to be in standard form, this number in front of x squared needs to be a whole number. It can't be a decimal. So in order to make this a whole number, I want to move this decimal. And if I move the decimal for this, I have to move the decimal for this term and this term. And so that's what I'm going to do. I'm going to scoot this decimal one place so it's behind the 5. So this becomes 5x squared. And as long as I do the same thing to every other number in the equation, I'm cool. So I'm going to move this decimal once here, so this becomes 55x. And then my decimal here is right here. You can't see it, and if I scoot it over, I have a hole that I have to fill in with a 0. So it becomes plus 120. This is your equation in standard form. You can't have a fraction or a decimal in front of the x squared and be in standard form. It has to be a whole number. So now it's a whole number. All is well. This blue one is standard form. So let's do one more. Number 5 here says to find the quadratic function in standard form that includes the values in the table. Well, they give you the table, so it's the same thing. We're going to put these in our calculator. So we're going to go back over here. We're going to go to Stat. We're going to go to Edit, and there's numbers here now. It's okay. We can just type over them. So I'm going to replace those numbers with 2, 3, 4. So I'm going to type in 2, enter, 3, enter, and 4, enter. And it just types over them. It's all good. Then in list 2, I'm going to go over here, and I'm going to type in 3, 13, and 29. 3, 13, and 29. And just like before, I typed over them. It's good. So now I'm going to press Stat. We're going to calculate again, and we want the quadratic regression, so number 5. Hit enter until it calculates. And so here's what we have. I have a is 3, b is negative 5, and c is 1. So to be in my equation in standard form, it's going to be 3x squared minus 5x plus 1. This is the equation in standard form of the quadratic that makes those values. So there are ways to do it. If you're just given the solutions, rewrite them back into their factors by setting them equal to 0 and then multiply. If it's a complex function, do the same thing. Set it equal to 0 and then multiply. You just have to might distribute more than twice. Just be very careful drawing your little rainbows so that you can do that. And then if you are given 3 different points, like here and like here, plug it in your calculator, have it find it for you. So there are some ways you're going to do this. So for your homework, open up your homework packet. Let's talk about the numbers you need to do. So for your homework, you have 2 pages left in your packet that have not been done. You need to complete all of page 2. That's the one that's about the vertical motion problems. And then on page 3, you need to do all except number 5. You may cross out number 5, but then you need to do the rest of them. And I know that seems like a lot, but you do have a quiz tomorrow and you need to be prepared for it. I will be here after school today as well as before school tomorrow. If you happen to have questions, I will see you then.